welcome back to the series where I work on the Arduino R3 starter kit set. And today we're going to be tackling project 2, which is Spaceship Interface. That's what the project is called. And in this project here, if you're following along and you have the book in front of you as well, the ingredients we'll need, the parts that we're going to need is a switch, 3 LEDs, 220 ohm resistor, and 10 kilo ohm resistor, which I've already pre-assembled here. But before we get into that, I've already looked into the chapter here, and I want to start this video off by looking at the very last page of this chapter, which is on page 41. This one here it talks about how to read the color codes on resistors, which is so important. If you remember in my first video there, I was struggling to figure out what resistor I needed because it wasn't identical to what the chapter was, where it showed in the first chapter. It had a little picture of a resistor, and I was looking for the 220 ohm resistor, and if you remember, it looked like this. It was the beige one, right? But I realized that later that I had one that was similar to that, but it had 5 bands, and it was a blue color. Okay, it looked like this. It looked like this one. And so, without having this knowledge from chapter 2, now that I've read this, I want to go review this first before we move on with this project, because you're going to need this information to identify which resistor you'll need to put on here. Okay, and let's go over that for a second here. Resistors, they come in 4 or 5 bands. Okay, so 4 bands is right here and 5 bands is right here. Right, so how you read the color code on a resistor is by looking at the first one. And the first one normally is one of the multicolor, like different multicolor. So let's take a look at, let's pull up a resistor here. All right, so if we look at this resistor here that I was looking at in the previous project, where I was using it with the LED, you can see that the band on here is red, red, black, black, brown. Okay, red, red, black, black, brown. And that tells me how we read this resistor code is that each band will represent a number. And in this case here, we have red, red. All right, we have a 5 band resistor. It can even come in 5 or 4, okay? 5 is, in our case, this is a 5 band resistor, 5 band of colors, okay? So red, red. So red means 2. And the second one is also red, so that's 2. And the third band is black. So black, the third digit is 0. So we read this resistor as 220, so 220, okay? The fourth band is a multiplier. A multiplier is how many zeros do you add afterwards of the first 3 digits, okay? And in our case here, we have a black. Black means 0. So since the multiplier is 0, we just stick with 220. So in other words, what it's saying is there is no multiplier. Black is no multiplier, okay? And so we just stick with 220. The last band here, which is brown. Brown means a tolerance level of plus or minus 1%. What the tolerance level means is that this can be 220 ohms of resistance plus or minus 1%. Okay, so give or take, that's what it kind of means. And that's how we read a resistor. So that's very important to know, because in this exercise here, we have a second resistor that we will be using, which is, I believe, 10 kilo ohms, right? That's what I just said here. So what did I say here? yeah, 10 kilo ohm resistor. And that 10 kilo ohm resistor is right here. Let me just grab it, which is this one here. And it's going to be the one with a brown, black, orange, and gold band right there. Okay, and let's just take a look at what 10 kilo ohms look like. Okay, when we're reading it with this resistor color code here, brown is 1, black is 0, and because this is a 4-band resistor, okay, this is a 4-band resistor, we skip the third digit, we don't count that, and then the orange should signify a multiplier, and in this case the multiplier is 3. 3 means you should add 3 zeros behind it, so we would have 10,000, right? So it would be 1 0, then multiplier 3 0 0 0, that means 10,000. And then we have a tolerance level of 5%, which is gold, which is a gold band there. And so basically what it's saying is this is a 10 kilo ohm resistor plus or minus 5%. And that's how you read the resistor. So that's very interesting information, something that we definitely need to know for our future projects or anytime we're building something with LEDs. Cool. So page 41 if you want to review that on your own. But yeah, great. Okay, so in this chapter here, we're going to be building something that's a little bit more advanced than our simple series and parallel circuits that we were kind of doing in project 1. And here we have, you notice I took the Arduino apart off the board here because I basically wanted to match it to exactly how it looks like on the book here. So when I set it up, it's just a lot easier, especially on video or anybody that is reading along and doing this as well. I just basically had the layout exactly how the book is, and I wired everything up exactly how it is on here. So I followed the pins down to the T, and you can see here that's exactly what it is. Even though this is a little bit messier here, that's just because the wires are a lot longer, but just follow this diagram and wire this up exactly how this is. Okay, I will show you here what it looks like in real life. Okay, pause the video if you need to take a look at that, but it's exactly what it looks like in the book here. And let's just kind of go over, go over the overall of this, what's happening in this circuit. I'll need my Apple Pencil here, and let's just trace the circuit on what we can expect to happen, or how is it wired. And that's very important to know, to understand our own circuit or what we're trying to build. Okay, so I always like to go from the top, and the top normally means from positive terminal. Okay, and then we just kind of trace our way through there. Now we have the positive wire coming out of the 5-volt pin on the Arduino, which is this red wire here, right? And it connects to the positive rail on the breadboard. And this positive rail, it runs up and down, vertical, right exactly where you see this red line. It runs positive all the way down there. So even this pin here will be active with positive energy, okay? Right there and there. And so anything that's touching inside this vertical line on the positive will be powered. And let's take a look at what is powered here. We can see that I have a jumper going from this rail into the inner of the breadboard, all right? And where that goes is right into the first prong of the switch, okay? Now, we can take a look at this diagram here. It's exactly what's going on here. Positive down to the rail from the Arduino, going down, and it jumps right into the breadboard. And remember that inside the breadboard, everything is horizontal, where on the outside it's vertical here. Okay, so it jumps into the first prong of the switch. Okay, and when it goes into the first prong of the switch, which we have here, if this switch is pressed, this will allow current or voltage, or even let's just call it electricity, to pass through to the second prong of the switch here. And then from there, it will run down to the green wire and go back into the Arduino, which goes to pin number 2. Okay, pin number 2 is what we call a digital pin. And from pin number 2, if you look at your board here on the side, you can see that there is pin 0 to pin 13. All right, and then at the end there's a ground. Pin 0 and 1, these first two terminals are used for communicating with the board, so we don't use that. We're going to start using it from pin number 2. Okay, and so that's where this green wire is going to. This green wire will act as an input for the Arduino. What that means is that when it's going to read what's happening with this switch. It's going to know if this switch is pressed or not just by detecting the voltage that goes into this green wire. So if I press it, if I power it on, I press it, voltage should go into here and jump this green wire, and it acts as a signal, and the Arduino will know that, hey, I'm seeing voltage on this line here at pin number 2. That means this switch is pressed. But once we have 0 voltage, if I let go of the button, that should mean that there should be no voltage here. Okay, and today I brought my multimeter. All right, this multimeter here, we'll do a whole test on it just to verify exactly what I'm saying, and we'll have it nice and dandy so we can all understand what's going on in the circuit here. Let's talk about this resistor here. This resistor here is a floating this resistor here is a pull down resistor. What is a pull down resistor anyway? Okay, because when you look at this switch, when positive voltage goes through this jumper wire, this orange one that I have here, which is a red one depicted on this diagram here, and it goes through the switch, right? It goes to the switch, the first prong, and when I press the switch, that will jump over to the second prong and then go into this green wire, and we should see 5 volts right here when I press the switch, right? And when I let go of the switch, it should be 0 volts here, right? And so right now, this right here, this green wire should be 0 volts since I don't have this pressed anyway. So why do we have a resistor right after this green wire? Why do we have it on the same circuit that's connected to ground? Now, this is where a lot of people get confused, even myself sometimes, but let's take a look at what the description of a pull down resistor is. I think in the book it says this. It says it connects the pin to ground when the switch is open. So it reads low when there is no voltage coming in through the switch. Okay, and when you read that, it's kind of confusing because you're like, well, there's no voltage going into the switch anyway because the switch is open. I'm not even pressing it, right? That's true. That is very true. In a perfect world, let's say for instance, in a perfect world, this would always read 0 when I let go of the switch. It'll say 5 every time I press it, right? In a perfect world. But what you don't realize is that a lot of times these conductor wires, this wire here will capture noise. And how does that happen? Well, through magnetic field. Like it could be from a positive wire that's right adjacent to it, or maybe another equipment that giving out a huge magnetic field. And if you know, in electricity, just almost think about like your wireless charger for your phone, right? How does that even work? The wireless charger creates a magnetic field that cuts through conductors that's inside your phone, and in order to create current to charge your phone, right? So that same concept happens with wires like this that is so simple. And sometimes what happens is that we may not even know about it. Maybe, you know, the wire beside it cause enough magnetic field current to cut through this wire, right? When I mean cut, I mean just like invisibly, right? Because magnetic forces, you can't see it. But it's enough for it to create a tiny voltage that possibly could be zero point 0.1, 0.001, something like that, right? And that's enough to make interference with this pin number 3, which is trying to read if this switch is pressed on or off or not, right? The only way this signal wire going to number 3, this Arduino, would know if this switch is pressed or not is if there is 0 or 5 volts on this wire, right? And if it sees maybe like 0.1, it's going to think that someone's pressing this wire, this switch, right? And in that case, that will mess up our whole circuit because that's not what we want. So how do we make sure that every time that we release this switch, this wire always reads 0? We use a pull down resistor, right? In case it's more of like a protection device to make sure, like insurance, that we will always get the same right reading. Because in case that there is interference in this green wire, 0.1, 0.2, whatever, that voltage will always go through this resistor, get used up as heat, and drops the whole circuit down to 0. All right? Does that make sense? Because if interference is going through this green wire, let me just say it again. If there's interference going into this green wire, it's creating a voltage. Like, let's just call it positive energy, right? It's creating a little bit of voltage that needs to go somewhere, right? And it's not going to go back into this Arduino, because this Arduino is kind of just reading. It's just reading what's on this wire. It's not going to consume that voltage. So we need to allow that voltage to go somewhere, and that voltage, that little tiny interference voltage, will go through this resistor and into straight to ground. Okay? And it's not going to be able to go back into the switch because, you know, the switch is open. Like, there's nowhere for it to go. So electricity likes to go through the least amount of resistance. Electricity is very lazy. It'll go to the place that's the easiest to flow. And so in this case, this open switch is infinite resistance. It's going to have to try to jump through an air gap inside the switch, so it's not going to go there. So it's going to go through this higher ohm resistor and straight to ground and completely be consumed by this resistor. So I hope that makes sense what a pull down resistor is. And it's just basically to make sure 100% that we're going to get a 0 volt reading in case there is any interference inside this wire. Okay? All right. So since we've gone past that point, now let's take a look at the other parts of the circuit here. So in this diagram, you see that we have 3 yellow wires, right? These 3 yellow wires are connected to number 3, 4, and 5, the pins, the digital pins on the Arduino. And what these are is that we are going to code this, program it to be outputs. Okay, on the Arduinos you can program these pins to be inputs or outputs, and when you put them as outputs, they will send 5 volts out into each wire. Okay, and so in this case, these yellow wires, you can think of them as positive battery, right? 5 volts, they're just an extension of what this is. Okay, they're an extension of what this red wire is. And the reason why they have it plugged into the pin is because we want to be able to control these LEDs right here, right? We don't want them all on at the same time. We want to be able to computer control them on and off. And that's why they're using a control circuit where they're controlling the positive wire, the 5 volt, okay? So these three are wired in a way where you can see here that it runs to the long side of the LED, okay? Let's take a look at the LED again. This is sort of a review if you've just jumped into this thing. An LED will have a long wire and a short one. Long and a short, you see that? Is that better? Yeah, okay. Long and a short. So the long one is positive, the short one is ground, negative. So when I stuck it in with the long side going to the yellow wire. And if you, as a review, the breadboard inside the middle here runs horizontally, and the ones that are on the side run vertically, okay? So horizontally, have it plugged into there. So the positive LED, and then right beside it is where the negative leg goes in, and right after that negative leg of the LED, I have the resistor going into it and going straight to ground, okay? So just follow this diagram here in the book. All you're doing is making sure the LED has a positive voltage, which is this yellow wire. It will run through the LED and then right down to ground, and then from the ground side it's going to have a resistor, which is 220 ohms, and then that is going to go straight to ground, okay? And then once it goes straight to ground, it's going to come out of this ground wire here and into the ground terminal of the Arduino. So basically that's our circuit, right? This junction here, this little part where all the LEDs, they're just basically waiting to be powered by this yellow wire. That's what it is. And this computer is going to power them. It's going to pulse it, and allow it to flicker or whatever we're going to program it to do, okay? Whereas this section here, you can see that clearly it's going to be an input terminal for this board, because how do we let the computer know that we want these bulbs to flicker differently? When we do that by making sure we wire in a button, and that button will change the voltage from 0 to 5, and it'll allow the board to know when we've pressed that button in order to execute the blinking of the lights. Does that make sense? I hope that makes sense. Okay, so this section here is our input section, and this one here should be our output. What we do over here would output the results over here. Input and output. Every circuit will have that. Okay, so that's basically the overall view of this circuit here. Take your time, spend your time, and really when you build this circuit on your own, I pre-built this just to save some time on the video, so I don't have to like struggle through it. I do notice that it's sometimes, especially with a new breadboard, it's harder to stick stuff in. Just take your time and make sure you don't short anything out, okay? Because these components are so close to each other, make sure you don't have anything pressed against each other, especially with the positive and the negative terminals. That will really mess this board up, and it can fry a lot of stuff, and it's not good. So just be very careful, all right? Now, once you have it built, let's move along with the video. All right, so what we have to do now is in this chapter, what we're kind of just building is something kind of fun, kind of, I don't know, it's called Spaceship Interface, because what they want us to do, or what this is supposed to be doing, is when you take this template here that comes in the box, and you take out the holes and stuff like that, on here it says system ready, engage hyperdrive. Okay, take a look at that. And this is where the button will go. All right, and if we fold this up, it should look something like, it should look something like this. And that's kind of like what we're just kind of building, is just like a really fun remote thing, and we can pretend that we're taking off into space or something like that. And my guess is that when you press this button, it's going to light up, I don't know, the red one, the green one, something like that. System ready. System ready tells me that this will be automatically green if we don't have the button pressed. And if we press it, it's going to do something with these red lights, because that one it says engage hyperdrive. So I don't know, maybe it'll start blinking or something. Just a little bit of fun for a little bit of a step up from the previous project where we were doing series and parallel circuits, right? So this is putting series and parallel circuits into play here, right? Series and parallel circuit. Let's just do that real quick here. We can see some series and parallel circuits in this right now, right? We have, let's take a look at this yellow wire. This yellow wire will output 5 volts, which is positive, right? And it'll go through the LED, and then from the LED, it'll come out of the resistor and into ground. That's a series circuit, right? If you take any of these components out, none of them will receive voltage from this yellow wire at all. Then that's a series circuit. Now, where do we see a parallel circuit? Well, we see a parallel circuit right here in the input side. The parallel circuit is, we get the 5 volts from this red rail here, right? Which is this orange jumper here that I have. And from there, it goes into the first prong of the switch, right? And from the first prong of the switch, it goes into the second prong. And then from the second prong, it goes into this green wire. But notice that we also have a resistor on the same horizontal. So whenever I press this switch and the 5 volts comes in through the switch, we're going to see 5 volts here, and we're going to also see 5 volts here at the resistor. That means that these two components here, this wire and this resistor, are wired in parallel to the switch, right? I mean, let's test it out. I mean, this is very basic. If you already know this, you can skip forward to the video, but I just wanted to, I have my multimeter here. If you know this, you can skip this part. I'm just going to test this out just to prove that this is in parallel. Plug it in. We have our green light here to know that it's powered on. And let's just see, from this jumper wire here, I want to see if I get 5 volts, okay? And this should be ground, so I'm just going to touch the resistor and this jumper wire. I'm going to be very careful not to touch these two together, because if you touch these, this will short. So be very, very careful if you have a multimeter with you, that where you prod and poke can be very detrimental. So just be very careful. I'm just going to put this on the negative for the resistor here, because I need a ground point. And I'm just going to touch right here. All right, see, if you see in the multimeter here, do you see that? Yeah, I hope you do. I got 5. Let me just make sure you see this. Yeah, okay. You see that? Yes, I think you see it there. So what I'm going to do is right here and right there, just to confirm that I have 5 volts coming in. Yes, 4.97, very close to 5 volts. All right. So just to test, if I press this, I should get 5 volts here coming through this green wire and also this resistor, just to confirm that we're on a parallel circuit, right? Let's just see here. So I will keep this at ground, which is going to be the back of this resistor. And if, I need 3 hands. So actually what I need to do to be much safer is there's a second ground terminal on this Arduino here. If I just put this wire here, all right, which has a bare piece, I'm just going to put an alligator clip on there and clamp this terminal onto there like that, so I don't have to worry about the ground part, so I can press the switch. Mate these two together with an alligator clip like so. All right, so it's touching. All right, so I don't have to worry, and I can have a second hand to press the button while I'm measuring. And just to confirm that this is, together and we're actually clamped to the ground, I just touch right here and I have, yep, I have 4.97 volts, so I have a good ground. All right, and so right now when you look at this green circuit, it's 0 volts, right? If I press it, the button, there you go, 5 volts coming in. Same with this thing here. Right now, switch is off, press it down. There you go, I got 5 volts as well. Let go, gone. 5 volts, gone. All right, so that tells me, that confirms that these two are linked together. This is part of a parallel circuit there. Okay, super cool. Now, just to really simplify it even further, if you're really new to electronics, let's take a look back at the diagram here on chapter 1, and looking at this, you can assume that here is a parallel circuit, right? This, imagine the switch is right here, and when I press the switch, the 5 volt goes into here, goes into the green wire. Just imagine this circle is the green wire, all right? And then the second one here is the resistor, all right? And then they both go to ground. Now, that just confirms to you, like when you take a look at this right here, this seems a lot easier to read than when you look at a diagram. I mean, like when you look at it on the breadboard, it doesn't make sense, right? Naturally, it's kind of hard to figure out. Like when you look at these components, it's harder to trace that this is a parallel circuit. Now, a lot of you may ask, well, what about the ground? Where is the ground here? Like this green wire is not grounded, right? It's not going through here. Well, actually, there's grounding through the board, all right? There's ground through here, and that's the reason why I can read the voltage here. And so, yeah. So I hope that makes sense. That should be enough for that. All right, so let's continue on with our project here. In our project, we are going to need to, once you've assembled this, we're going to need to write code for this. All right, that's what I think in here. That's it talks about, when you read this here, it talks about what code you could write in order to activate the pin. And each one of these digital pins here, you can change it from an input to an output. I think I mentioned that earlier. You can change from an input or output. When you change it to an input, it's going to just wait for a signal to let, high or low. In electronics, when you say high, when a signal is high, it just means that there's voltage there. When you say a signal is low, that means there's no voltage there, 0 voltage, okay? Something to note when you do, I think, the programming of this. And I think, just like the first project where we were making this yellow light in here blink, and how I uploaded a sketch. If you're new to this as well, a sketch just means a program, right? In programming, you call a program where you code stuff. In here, they call it a sketch. So we'll just stick with what they say here. It's a sketch, and they should have a pre-programmed sketch already in the software, the IDE, that we can upload onto here. Okay, or if you're very, if you're adventurous, you can code this out yourself. They give you all the answers here. This is exactly what you need to code out here. All right, and look, reading this code here, I do have a little bit of knowledge of code. I can see that what's going to happen is these two LEDs will start blinking once we press this light. And yeah, you know what? Let's take a look at that on the computer right now.